Welcome to this explainer, brought to you by Forge College. I am absolutely thrilled you're here today because we're tackling one of the most satisfying aha moments in Web3 development, listening and processing events off-chain. Now, in our previous lesson, we went over traits and abstraction for reusable functional code, but today we're talking about communication, specifically how the outside world actually knows what your smart contract is doing. Because let's be real, your smart contract isn't exactly going to send you a text message when something happens.
So think about this for a second. If a contract emits an event, but no script is listening, did it really happen? It's the classic tree falling in the forest question, but for the blockchain. Let's break this down. A smart contract emitting an event is basically like a radio broadcasting a signal out into the vast cryptographic void. It honestly doesn't care who is listening. It just screams out, hey, an item was updated. And if you want your decentralized application's front end or your backend database to actually know about that update, well, you have to build a literal radio receiver off-chain to tune in and hear it. And that is exactly what we're building today.
Here's our engineering schematic for today. We'll start with the blockchain broadcasting station, then assemble our toolkit, check out the decoder ring ABI, tune into topics, actually build the listener, and finally handle real-world static. Let's jump in.
Part 1. The blockchain broadcasting station. Because emitting is really only half the story. Think about your user experience. If someone buys an NFT on your smart contract, but your website's interface doesn't update, your app is practically blind to the user. They're going to think it's broken. That's exactly why we need an off-chain listener. By definition, this is just a script that connects to an RPC provider, registers a filter, and receives logs in real time. We map that on-chain behavior directly back to predictable actions in our app. For our purposes today, we're just going to log it cleanly to a console, but out in the wild, this is exactly how you'd trigger a database update or fire off a push notification to a user's phone. Moving to part 2, assembling your toolkit. Let's look at the parts we need for our receiver.
We're going to build this against a local Hardhat node. Why? Because it gives us a pristine, zero-cost laboratory with predictable accounts. Here is our minimalist bill of materials. We literally only need 4 small files. First up, listener.js, that's our actual radio receiver. Second, emit.js, this is our broadcaster to manually trigger the contract. Third, our ABI JSON file, think of this as our translation manual. And finally, a simple .envam file to securely store our environment variables. We'll use the ethers library and .envam to wire the whole shebang together.
Which brings us to part 3, the decoder ring API, or translating the static. So when our receiver catches a broadcast from the blockchain, it absolutely does not arrive as a beautiful, human-readable sentence. It arrives as pure static. Look at the raw log on the left here. It's just a messy, unreadable wall of hexadecimal bytes. Gross, right? But check out the parsed log on the right. We suddenly have structured data with named arguments like owner, ID, and data. The ABI, the application binary interface, is the magical decoder ring that transforms that messy hex block into beautiful, usable data your application can actually understand.
Part 4, tuning into topics to find the right frequency. Now, we obviously don't want to listen to every single transaction happening on the entire Ethereum network, right? That's where topics come in. A topic is an on-chain value created by marking an event parameter as indexed. It acts exactly like a specific radio frequency. Instead of downloading all the chaotic global noise of the blockchain, we can just tell our RPC provider, hey, do me a favor and only send me the logs that match this specific topic frequency. All right, part 5, let's actually build the listener and wire up this circuit.
It is time to roll up our sleeves and open up that listener.js file. Just follow these 4 logical steps. Step 1. Connect to our node using the JSON-RPC provider and our .env URL. Boom, we're plugged into the wall. Step 2. Construct our filter using the specific contract address and the event topic signature we want. Step 3. Turn the radio on. We do this by registering a callback function using provider.on. And finally, step 4. Whenever a log actually hits our receiver, we parse it using our ABI interface, converting it from raw hex into readable text. But wait, to test our shiny new listener, we need something to actually listen to. That's what our emit.js script is for. This is just a tiny utility script. It grabs Hardhat's default local signer, which is awesome because we don't have to mess around with managing private keys right now, and it calls the contract function to emit our event. It waits for the transaction to mine and then prints the hash. It's essentially just acting as our broadcaster, safely firing off a test event locally so our listener has a pitch to catch. And boom, when we run these 2 scripts side by side, we hit our checkpoint.
Just look at this terminal output. Listening for item updated events. It caught it. The parsed arguments mapped perfectly, and even the non-indexed arguments were decoded flawlessly by the ABI. We also grabbed the raw block number right there, telling us exactly when this state change happened in the chain's history.
Finally, part 6, handling real-world static and dealing with interference.
Look, getting this working locally on Hardhat is great, but real public blockchains, they are chaotic thunderstorms full of interference. You are going to encounter silent failures. So here is your troubleshooting checklist. If you use the wrong ABI, you'll get immediate parse exceptions thrown in your face. If you use an incorrect contract address, your script will just return total, maddening silence. And if you have missing or wrong topics, your filters will just fail. I'll tell you right now, ABI mismatches are, without a doubt, the most frequent culprit for these headaches.
You also have to design your off-chain systems defensively. Real-time log delivery on a public chain absolutely does not guarantee finality. You might receive logs totally out of order. You might get duplicate logs from random network hiccups. You might even experience transient chain reorganizations, often called reorgs, where the blockchain basically briefly changes its mind about recent history. Because of all this chaos, your application must be idempotent. That's a fancy way of saying if it processes the exact same event twice, it won't break your app or duplicate data in your database. We achieve this by utilizing the raw block number and transaction hashes as unique resumable processing markers.
To sum it all up, connecting an off-chain process bridges the gap, allowing your application to react deterministically to the blockchain's broadcast. You've successfully taken invisible, ethereal signals and made them tangible and actionable in your app. But I want to leave you with this somewhat provocative thought to chew on. If your centralized off-chain listener goes down, does your supposedly decentralized app even exist to the end user? Food for thought, right? In our next lesson, we're going to dive deep into diagnosing those complex network reorgs we talked about. Be sure to visit forge.college to explore this and tons of other Web3 topics. Thank you so much for learning with Forge College, and I will catch you in the next explainer.